Unit 5 should be a review, mostly. We have exponential equations or exponential functions and logarithmic functions, and they're inverses of each other, and you've done all this exponential stuff ahead of time. So this should be mostly a review, learning targets 1 through 6. Then we'll get into logarithmic stuff, and you do need to know about log stuff for calculus, all right? So we'll need to get into all of that. You did a little bit in Algebra 2, which is a little teaser, and so we'll get into some more in-depth things here in pre-calculus, all right? So today we're talking about exponent rules. Learning target 1 and 2 are definitely review, okay? On your note sheet, you have all the exponent rules. You know them, you've seen them. If you have questions about them, you can ask, but I know that you know them. So learning target 1 is asking to evaluate expressions involving exponents. I know that most of you guys are just going to go through and type them all into your calculator, and that's totally fine. I won't ask very many of these on the quiz, but I do want you to understand the exponents and kind of get you a reminder. So for the first one, if I want to rewrite this with no negative exponent, what do I need to do? I need to write it with the reciprocal, so 1 over 5 to the 4th. And since we're evaluating, we'll figure out what 5 to the 4th is, so 1 over 625. Okay? On number 5, another negative exponent. Here I might want to multiply by the exponents inside the parentheses, and then get the reciprocal. And so you end up with 256 over 81. On number 6, you have a fractional exponent. So again, I'll remind you the numerator is the exponent, and the denominator is the root number. This is the cube root of 216, all to the first power. So the cube root of 216 is 6, and 6 to the first power is 6. On the next one, you have two radicals being multiplied. They're both square roots, so since they're both the same, you can multiply. And so what do you do to the numbers inside the radicals? You multiply them. So you get the square root of 81, which is 9. On the last one, another fractional exponent. The denominator is the root number, 5th root of 32 to the 3rd. Well, the 5th root of 32 is 2, and 2 to the 3rd is 8. That's it. That's learning target 1. I know. Super easy. On learning target 2, we're simplifying because we're going to have variables, all right? Generally, I don't want negative exponents, and it'll tell you normally if you want a radical or not. So on the first one, I've got a 3 on the outside of the parentheses. I'm going to multiply by all the exponents inside the parentheses. That becomes 3 to the 3rd and a to the negative 6. I'm multiplying by another term. So you multiply by another term. You can add exponents for like variables. So you get 3 to the 4th and a to the negative 1st. I don't want negative exponents. So that's 3 to the 4th over a. And 3 to the 4th is 81. On the next example, you're multiplying radicals again. We just did one where you multiply the numbers underneath. So if you're multiplying these two terms underneath, you're adding the exponents. So you get the square root of m to the 7th n to the 7th. I want to rewrite this without a radical. So the 1/2 power. That would be nice. I went ahead and distributed. And then one more on this side, we have a 1/2 power. You could write that as a square root, but since we have all these exponents on the inside that will probably reduce, we're going to go ahead and multiply by all the exponents. You get 2 to the 1/2, x to the 4/2, y to the 8/2. So when you reduce, you can't take the square root of 2, so 2 to the 1/2 stays. But then you get x squared, y to the 4th, because those fractions reduce. This makes it a little bit neater. 4 more questions for learning target 2. Express using rational exponents. That means we want fractions. So this is a square root. This is 169 x to the 5th all raised to the 1/2 power. So the square root of 169 is 13, and then x to the 5/2. Right, because you would have 169 to the 1/2, which is square root of 169, which is 13. On the last one, you would take everything inside the radical, raise it to the 1/4 power. Right, so then you would be able to multiply all the exponents. So you get a to the 2/4, b to the 3/4, c to the 4/4, d to the 5/4. So you get a to the 1/2 power, d to the 3/4 power, c, and d to the 5/4 power. Just reduce what you can. And then last side, express using a radical. It says a radical. It means one radical. All right, so it has to have all your fractional exponents have to have the same denominator. And the first one they do, they all have a 4. That makes this the 4th root of 6 to the 1st, b to the 3rd, c to the 1st, or just the 4th root of 6, b to the 3rd, c. On the second one, though, we can leave the 15 out of the radical because if you put it into the radical, you're going to end up taking that root anyway, you get back to 15. But for the exponents, I have 1/3 and 1/5. So I need one denominator. So the least common denominator is 15. So I need to multiply both of those fractions in order to get a common denominator. So what do you multiply 1/3 by to get something over 15? 5. So you have x to the 5/15. And y to the 1/5, you can multiply by 3, so 3/15. All right, so I have the 15th root of x to the 5th, y to the 3rd. That is all of learning target 1 and 2. I'm going to do that very quickly, but we've seen these before. So when you're working through learning target 1 and 2, if you have questions, please ask me, but you've seen these exponent rules a million times.